Today we're given a graph and we are going to come up with the equation of a piecewise function. So as a reminder, a piecewise function means that we can have multiple parts or expressions of a graph all on the same xy axis, and they are differentiated based on what the domain is. So I'm going to start by just labeling this A and B. We're going to come up with the equation of both A and B as well as the domain. So I'm going to start and I'm going to set up what looks like my piecewise function. And I'm also going to look at what the domain is for each A and B. So the domain for A is negative infinity all the way to -1, and we have an open circle for A, so therefore we have a round parentheses. For B, the domain starts at -1 and goes to +2. At -1, we have a square bracket because it's enclosed, and at +2, we have a round parentheses. So now I have the domain for each part of my piecewise function. I'm going to go over and I'm going to write those on the on the right hand side. So negative infinity to -1. And -1, 2. Now we need the equation for each line. So we're going to focus on A again. The slope of A rise over run is 1 unit over 1 unit. And the y-intercept, now this is where it gets a little bit tricky. We don't actually see a y-intercept, but let's just imagine that this, let's just imagine that this graph continued. It would go through the point 0, 2, which means that the y-intercept would be 2 if it continued. So the equation of that line is x plus 2. So I'm going to write that on the right-hand side. And the domain restriction is from negative infinity to -1. Now let's look at B. The equation of this line, it's a horizontal line, so it has a slope of 0. And what is the y-intercept? It's -1. So this simplifies to be y is equal to -1. And we're done. That is the equation, or the equations of our piecewise function. The next thing we can do is actually evaluate our piecewise functions. So what that means is the question is going to give us an x value, and it wants a y value in response. So the most important thing to remember here is that the x values can only be plugged into one of the two equations above. So for the first one, A, it says x is equal to -3. So I check and see which domain -3 falls into. Does it fall into negative infinity to -1? Or does it fall into -1 to 2? It falls into the first equation. So that means I'm going to plug it only into the top equation, which is x plus 2. So -3 plus 2 simplifies to be -1. We can even check our work over on the graph. If I go to x is equal to -3, we do have a point at -1. And we're done. We only have one answer. The next question is saying when x is equal to 1. So we look at 1, we look at which equation x is equal to 1 falls into. So does x equal 1 fall between negative infinity to negative 1? Nope. Does x is equal to 1 fall between negative 1 and 2? Yes. Now this one's a little bit more complicated because there is no x to sub it into. So all we do is we take that negative 1 and we put it down below. What that really means is that we have a coordinate when x is equal to 1, the y value is negative 1, and that is true if we check on the graph.